Hey guys, welcome back to Trick Code. Today we're doing another Brainstellar Quant puzzle. This one is called 100 light bulbs. This is an easy problem. Let you guys go over it once. So the setup is pretty simple. There's 100 light bulbs in a room and there's 100 people, right? Now what happens is the first person goes into the room and toggles all the bulbs which are multiples of 1, which are multiples of his own number. So that means because every number is a multiple of 1, he basically toggles each and every switch. So all of them become on. Then number 2 goes in, and since all multiples of 2 are 2, 4, 6, and all those even numbers, all those even numbers are switched off because uh, they were on because of number 1, so they get switched off because of number 2. Right, so then number 3 goes in and he toggles all the numbers that are multiples of his number. So that would mean that, for example, 6 was switched on by 1, by 2 it was switched off, and now by person number 3 it was switched back on. But for example, number 9, so number 9 was switched on by person 1, it wasn't touched by person number 2, and then it was switched back off by person number 3. So this is how the game works, and each and every person gets their turn to go in, right, in increasing order. And we've been asked that without actually trying to simulate all of the 100 people going in and like switching on and off all the switches, we have to try to figure out how many bulbs actually, after this, how many bulbs are on, like how many of the remaining bulbs among the 100 bulbs in the room would be on after this entire process. So the hint I'd like to give you guys for this problem is to try to think about, for a particular number that says at random 66, or any number x for that matter between 1 and 100, try to think about the number of factors that particular number has. So coming to the proper solution now. First of all, let's start by asking ourselves that for a particular number, say x, right? How many times will it be flipped? That's eventually what we want to know, because if it is flipped an odd number of times, yeah. So since it was initially off, each bulb was off. If it was flipped an odd number of times, it would end up being on, which is the case we want to find. And if it was flipped an even number of times, it would end up off, right? And this is the most important part to think about. A bulb numbered X is going to be flipped between on and off states by the people or by a particular person who has a number which is a factor of X, right? So this is why we need to find out the number of factors. Just to take a quick example, say X is equal to 9, which means bulb number 9. For that, it's going to be flipped by the person 1, person 3, and person 9. And as you can see, all these three are factors of 9. This is why this question becomes important. Now the new question becomes, for any value x, we basically look at the number of factors. And if the number of factors are odd, this would mean that it will eventually be on. And if the number of factors for that x value is even, it would be off. So basically this just becomes parity of factors of x. This is the question we have to ask now. And as you start to start calculating number of factors for values, you'll start to notice a pattern. What the pattern is, basically, if you guys want to pause right now to try to figure it out yourself, is for any number y, it's usually going to have an even number of factors. Why is that? Because factors always come in pairs. So let's say we take 12. Now, one of its factors is 4, but since 4 is a factor, it has to have another factor which is getting multiplied with it in order to produce 12, right? And the number over here is 3 actually. Common to see factors come in pairs always. There's only one special case where there's only one number and the pair of the number is the number itself. And for example, 9 over here. So 1 has a pair of 9. So these two become a pair and these two are factors. But what do you see when you try to figure out the factor pair of 3? It's the number 3 in itself, right? Now, because of this property, we only count this factor once. So there's 1, 2, and 3. 3 factors, which is an odd number of factors, right? And this only happens when a factor can be multiplied by itself to produce the x value. So we need to find x values which include a factor, let's say y, which when multiplied by itself will produce x. Well, that only happens when x is a perfect square and its root is the value y. So we come to the conclusion that in order to have an odd number of factors, the value x has to be a perfect square. And how many perfect squares are there between 1 and 100? 10, right? So this is the answer. We already know without actually going through all of those 100 values that only the perfect squares will remain on by the end of all of this, which means that there's only going to be 10 bulbs on by the end of the entire process. Thank you.